Good evening, folks. We have an integer that's implicitly defined by this factorial expression. And another way of stating what we're trying to find is we're trying to find out that remainder r. So this reads I is congruent to r mod 23. So it's useful, at least for me, to write it that way. And of course, r will be a number between 0 and 22 inclusive. Now, the very first step is just to get I all by itself. Okay, so we multiply through by 31 factorial, and we get I isolated right here. And another important thing to note is that each of these terms are integers. 31 factorial contains a factor of 2, hence it's an integer. 31 factorial contains a factor of 3, it's an integer, and so on. So these fractions are actually integers just because of how you define the factorial function. Okay, so I is indeed an integer. Now, the way to get to this from a mod 23 perspective is to do the natural thing. Modular arithmetic is about division, right? So we divide I by 23. Now, I didn't explicitly do it, but it's clear that all the terms except for 31 factorial over 23 is not divisible by 23, right? It's a little confusing to look at this, but remember 31 factorial divided by 23 is an integer. 31 factorial divided by 23 is an integer. So this we'll continue. Now, what that means is all of these, everything except all the ones in this form, let me just write it out, what I'm trying to say a little bit more clearly. That would say that 31 factorial over k is always going to be congruent to 0 unless k is 23. Okay, it's going to be congruent to 0 mod 23, that's understood, mod 23, unless k is 23, provided k is not equal to 23. Now, I'm talking about the numbers in this range also, folks, from 2 to 31, okay? So as long as k is not equal to 23, all the other terms are going to be 0, right? And so that leads to a nice simplification right here. And I just restated what I said right here. It's clear all the terms in I over 23 except 31 factorial divided by 23 are divisible by 23. But being divisible by 23 is the same as saying you're congruent to 0 mod 23. Remember, 23 is congruent to 0 mod 23. Okay? So at this point, we're just going to simplify from a modular arithmetic perspective. Okay? So this is the only term that's non-zero in our expression of interest. Okay? So what we do right here, folks, is get to this stage. All right? Now, again, don't forget that 31 factorial over 23 is congruent to 0. I mean, that's all we have to analyze from a modular arithmetic perspective because the rest of the terms are 0. Okay? So, now, this is a big leap of faith right here. How in the world did this happen? 31 factorial over 23, and all of a sudden all this stuff disappears right here? Well, do remember the special result here, 22 factorial, okay, is congruent to 22. You're used to seeing -1 here, so I'll write that. But that's congruent to 23 minus 1, which is 22. Okay, and it's more useful to use this form. Okay, just from, I guess you could use -1 in there if you wanted to, but it doesn't, you're going to have to make conversions in any event. But again, -1 and 22 are separated by 23 on the number line, all right? So you see all this, folks, right here? This part right here was 22 factorial. This circled part is 22 factorial. So you can leave the 1 out. The 1 doesn't change it, does it? It doesn't. So it's 22 factorial is that object. So you see how we replaced 22 factorial with 22 since we are dealing with a congruence. I think that's pretty neat because these numbers they're super large numbers that you couldn't manage if you didn't have this kind of congruence reduction technique. Okay, so we got what we're interested in. We have I over 23. okay? I over 23, let's just not forget that's what we're talking about. We're dividing I by 23 and seeing what the remainder is, right? Okay, so now this step right here is pretty, 24 is congruent to 1, 25 is congruent to 2, 26 is congruent to 3, all the way to 28 is congruent to, right here, yeah, just right down here, 24 is congruent to 1, 25 is congruent to 2, 26 is congruent to 3, 27 is congruent to 4, 28 is congruent to 5, and 29 is congruent to 6, right? Okay, now, but we still have the rest of this stuff to look at, right? This is, well, I mean, we've got it simplified quite a bit, but we still, even though those are smaller numbers, there's still some work to do. So, and I'll just write this in underneath right here. So you have 22. Now, this piece right here that I'm parenthesizing, okay, that's equal to 24, right? But 24 is just congruent to 1. I'm going to write this kind of big here so we won't lose track of stuff, right? That's the nice thing about congruential arithmetic. 2 times 3 is 6, 6 times 4 is 24, and 24 leaves a remainder of 1 when you divide it by 23, right? Okay, now I'll parenthesize this piece right here. That's 30. And I won't extend the dot, but we're talking about what do you get when you reduce 30 mod 23? Well, you leave a remainder of 7, right? So we have a 7 right here. That's a 7, folks. Now 7 times 8 is 56. 2 times 23 is 56, so this would be 10. All right? So what we have right here, folks, and this is equal to 22 times 7 times 10 is 70, right? But 70 is also a nice number for us because if you divide 23 into 70, you get a remainder of 1, since 3 times 23 is 69, leaving a remainder 1. So this would be congruent to 22 times 1. Okay? See, and that does it. That means our remainder would be 22, that's equal to 22. Okay? So 22 is our remainder. And I like this problem in a number of ways. You had to do a little bit of algebra, and you had to recognize that Wilson's theorem played a crucial role right here, folks. Again, let me write underneath this. This is the same as the result you've seen in the number theory class that says p minus 1 quantity factorial is congruent to -1. Okay, that's how you normally see it, where p is a prime number. But it's useful to write it as 22 here, although you could have just left it as -1 if you wanted to. Okay, so again, recognizing that this clump of factors right here is the same as 22 factorial, and then knowing to use Wilson's theorem was the key, and it led to a circumstance where we had a much shorter list of integers to reduce modulo 23. Okay. So that does it. We're done, and let's come up here and just write it next to the, find the remainder, so that back up to this stage, our R would be 22. Okay, let me double check that's what I wrote down. Yeah, 22, okay. Yeah, I like the problem quite a bit. I thought the structure was very cool, because we're finding the remainder of a number that wasn't given explicitly. You had to get it algebraically isolated and then do a few things with respect to algebraic manipulation and then appealing to that famous result called Wilson's theorem. All right, thanks for viewing.